by a lightning strike. It was the first major disaster of its type caught on newsreel, and the shockwaves spread around the world. Just when public confidence in airships was reaching an all-time high, a tragic series of events culminated in the Hindenburg disaster, and in an instant, the airship era was over. Or was it? 60 years on, plans are afoot to build a new generation of massive airships, even bigger than the Hindenburg. Are they mad? Well, no, thanks to new evidence that disputes the original theory as to why the Hindenburg crashed. In the early 1990s, a NASA scientist based in Florida investigated an alternative theory. He believes the Hindenburg had a fatal design flaw, but one that had nothing to do with the use of hydrogen and more to do with a dodgy paint job. Dr. Addison Bain's theory is that a buildup of static electricity ignited the chemicals used to coat the outer fabric of the Hindenburg.
This is an actual piece of the Hindenburg. Look at that. On the other side, we can see the original stitching. History before our very eyes. Fantastic. Zeppelin coated the envelopes of his airships with a gooey substance known as dope. The chemicals in the dope provided weather protection, they made the hull smooth and aerodynamic, and the metallic particles reflected the sunlight, keeping the gas bags inside cool. But the combination of chemicals caused problems.
The actual nature of the chemicals were highly reactive, so when the electrical charge did flow across into the fabric, it caused those chemicals to react, and that's what started the fire.
With a replica piece of envelope fabric, the theory is easily demonstrated.
Yeah. You see the sparking?
Right, so that is the aluminium exploding,
That's the reaction of the chemicals in there.
Dr. Bain believes that the stormy conditions that night in 1937 had exactly the same effect on the Hindenburg's dodgy paint job.
Well, this new theory fits the pictures and surviving eyewitness accounts. Once the envelope was alight, the hydrogen fueled the flames, but it wasn't the cause.
So the Hindenburg disaster was a freak accident and not the inevitable demise of the airship as a viable way to travel. Armed with this knowledge, in September 1997, the Zeppelin legend was reborn in southern Germany with the launch of the first rigid airship for 57 years. An airship filled with inert helium that has learned the lessons of the past. The key to the whole design of these new airships is the modern materials used in the envelope. Basically, there are 3 layers: an outside layer for UV and weather protection, a middle layer purely for strength, and an inside layer to seal the gas. Consequently, these airships are much stronger and a lot less leaky than the old Graf Zeppelin and Hindenburg. The Zeppelin NT's lightweight structure means more helium is used to lift passengers and less to lift itself. And modern engine technology makes this airship both fast and safe to fly. These engines are 200 horsepower Textron Lycoming engines, basically the same sort of thing you'd find on a small 6-seater aircraft. Now, this is tried and tested 1950s piston engine technology. But what's new is that each engine swivels up about 120 degrees and turns into like a mini helicopter. This is what's known as vectored thrust, and it's used for takeoff and landing. Flying one of these airships takes a lot of skill. It's a sort of cross between flying a plane, a helicopter, and a balloon. Pilots need 1,500 hours of flying other aircraft before they're even accepted on the training course. Let's hope they'll make an exception. I think I'm going to have a go at this. I'm flying this on the stick, which is in my left hand, and I'm heading out towards the lake. I've reduced power because once we've taken off in helicopter mode, we've got full thrust, full forward now in the forward mode. I'm currently cruising at 80 kilometers per hour at 2,000 feet. No problems so far, but the hardest task, as with the original Zeppelins, is landing. Time to go back to helicopter mode. There is the mast truck, looking lonely and waiting for Zeppelin NT-07 to
get there. Just keep it straight ahead of me, using the stick, of course. And I'm coming down on it a bit like Stuka at the moment, which is not really what I should be doing. I'm 115 feet in the air at the moment. There's the mast truck coming towards me. We're all in swivel mode now. I've got to keep it right ahead of me. 61 feet now. I'm going to smash into the mast truck. Oh dear. Oh, bang! Smash into the mast truck. Not very good, really.
In reality, in the hands of properly trained pilots, these new Zeppelins have run daily tourist cruises over Lake Constance for the last 7 years with a 100% safety record. And they've paved the way for airships to start getting massive again. Armed with a new confidence in safety, here in this hangar, they're taking airships one step further. They're getting ready to build airships bigger than the Hindenburg. This is a working prototype for an airship which will compete with the world's largest container ships and military transporters. It's not about luxury air travel, it's about bulk cargo, faster than ships or trucks, and much cheaper and easier to operate than the biggest transport planes. Like the Zeppelin NT, this airship uses tilting propellers. And the entire structure of the airship is made out of a Kevlar material of various consistencies. It's light, it's strong, it keeps weight down to a bare minimum, which maximizes the ship's lifting power. The full-sized airship, the Skycat, will be 10 times the size of the Hindenburg. The gondola has room for the crew and 30 passengers or fully equipped Marines. But the main load will be slung underneath the gondola, 1,000 tons of cargo. That's 800 saloon cars or 12 80-ton tanks. If this airship proves reliable, it has the potential of being a cheaper and faster way of transporting cargo and military hardware over long distances than ships or trucks, having the distinct advantages of being able to fly in a straight line from A to B non-stop and land pretty much anywhere. But how will such a massive airship survive the unpredictable weather conditions of a battlefield or a long-distance cargo run? The really clever bit about this airship is invisible. It uses fighter plane computer software to operate the controls. So to defeat the old enemy, the wind, the computer works at a speed far beyond human reaction time to keep the airship precisely on course. Like all its ancestors, the Skycat will be one great big flying engine. An engine that has taken longer to evolve and has had more setbacks and revivals than any other in history. The Montgolfier brothers first flew a bunch of farm animals over Paris 220 years ago. Count Zeppelin pursued a dream of the ultimate flying war machine, and the designers of the Hindenburg turned airships into luxurious flying hotels. But perhaps at last, the airship is about to find its true calling as a giant, graceful cargo transporter. One thing's certain, though, they're the most massive engines ever.